Good morning, student. This is our unit 4, which is earlier called as a quantum mechanics, but according to our autonomous syllabus, it is called as the modern physics. So, here we have discussed already about the Planck's hypothesis also. So, I have already discussed this. Planck's hypothesis is nothing but it is all about the electromagnetic radiation which is quantized and occurs in finite bundle of energy which are called as photons. So we know that what is energy of photon? It is E equal to h nu, where h is the Planck's constant and nu is the frequency of radiation. So in 1900, Albert Einstein used this Planck's quantum theory to describe the particle properties of light. Einstein demonstrated that electromagnetic radiation, including light, has the characteristics of both a wave as well as consistent with Planck's theory as a particle, for which they have got Nobel Prize in 1980. So here are some of the properties of photons. So you should know this one is nothing but it is the energy of photon h nu. Then we know it is it is nothing but it is the particles of light, so its velocity is equivalent to the light velocity. The rest mass of photon is zero. Photons are stable particles. They do not have any electric charge, and hence it is not affected by any electric as well as magnetic field also. The irrespective of the intensity of radiation, every photon of frequency nu has the momentum. And momentum is nothing but it is expressed by this equation P is equal to h nu upon c. The dynamic mass of the photon is E upon c square, where E is the energy of the photon. Then photon can interact with other particles like electrons, which can be seen in Compton effect. Similarly, photons can be created or destroyed when the radiation is emitted or absorbed. During photon-electron collision, the momentum and total energy are conserved. Similarly, photons cannot be decayed. The energy possessed by photons can be transferred to another particle when it interacts with other particle, which we have seen in Compton effect also. Photons are not affected by the magnetic and electric field because it doesn't have any charge. Photons only exist as a moving particle, and it is the particle with a spin 1. Its spin direction is parallel to the direction of the travel. So this is all about the Compton effect, in which we have seen that there is an incident photon which is collide with this rest electron, and after the elastic collision the electrons get recoiled and photon gets scattered. In our class we have seen that photon scattered in upward, which is denoted with theta, and electron is recoiled in downward direction with angle phi. The scattered photon consists of the higher wavelength, which is denoted with the lambda f, whereas lambda I is the incident photon. The difference between this photon and wavelength, scattered photon wavelength, is denoted by delta lambda, which is called as the h upon m naught c 1 minus cos theta, which is the Compton shift equation. So in this manner, in Compton effect, we have got two components. One is the modified, another one is unmodified. This is called as the Compton effect. Now, existence of modified and unmodified component. Out of the large number of incident photon on the scattering material, some photon collide with the electrons which are tightly bound. So here we are discussing about the unmodified. So whenever there is a tightly bound electron, in that case we have to consider the mass of the whole atom. So therefore in Compton shift equation m naught is replaced by m, and therefore the equation is expressed as a delta lambda equal to h upon m c 1 minus cos theta. So where m is very large in comparison to rest mass of electron, and ultimately delta lambda will become 0. which shows that lambda I, which is equal to lambda f. It means that the primary radiation is not modified. Thus, we have seen that whenever the photon collide with the bound electron, it gives rise to the unmodified component, whereas when the photon and electrons, which is free electron, collide with each other, it gives rise to the modified radiations. So, from this discussion, we can conclude that these two components, which are modified and unmodified, it is coming due to the free electron as well as the bound electron. So, in this way, we can say that bound electrons are responsible for the existence of unmodified component, and free electron is responsible for the modified. Now, in your syllabus, most of the time we will ask you what is the statement of Compton effect, as well as you should know what is the law of conservation of energy as well as the momentum. So in Compton effect, since there is elastic collision, so it must satisfy the law of conservation of energy. And therefore, here you can observe energy of incident photon plus energy of rest electron equivalent to energy of scattered photon plus energy of recoiled electron. So we can observe from the diagram incident photon having energy h nu, whereas scattered photon having energy h nu dash. So therefore, we can write rest energy of electron is m0 c square. Photon energy is denoted with h nu or h nu I for incident, equal to h nu f. In many books, instead of nu f, it is written as h nu dash. So it is modified wavelength plus. It is basically the equation for energy of recoiled electron, which is expressed as C into P square plus M naught square plus C square. Yeah, you must have seen this equation also. Like this one is there. You can see this equation like this. In most of the books, it is expressed as P square, sorry, C square plus M naught square and C to the power 4. So don't get confused about it. It is one and the same. So I will just clear. Okay. So this is the law of conservation of energy, and now you can observe this conservation of momentum. Now here you must be careful because there are two components along x direction as well as y. So along x direction, since the photons are moving but electrons are not there, so initially photon momentum is expressed as h nu I upon c plus 0, h nu f upon c cos theta plus p cos of theta. Here also it should be theta. Similarly, the along y direction is expressed as along y direction, since electron and photon both are moving only along x direction. So before collision both are having zero component, whereas along y direction it is p sine of theta. So in this manner, the conservation law of energy and momentums are expressed. Here, remember that it is not mentioned theta, but it should be theta over there. Okay. So in this manner, this Compton effect is studied, as well as its conservation laws of momentum and energy also we have expressed. So for 4 marks, such type of questions can be asked. Now prove that free electron cannot absorb a photon completely. So here we are going to use contradiction method. We have to show that whenever the photon will incident or interact with the electron will not absorb photon completely, and for that purpose we are using contradiction method. So in this method, you can observe I have just put the law of conservation of energy expression. This is energy of incident photon plus energy of rest electron equal to 0 plus C. Now why this term I have taken 0? Because it is showing that if suppose it is um, photon is absorbed by the electron. So after collision, what will happen? This value becomes 0. And this is the uh, second part, which is showing that the the energy of the electron, and therefore we will get h nu plus f naught c square equal to c. And the momentum conservation expression becomes h nu upon c plus 0 equal to 0 plus p. So therefore h nu equal to cp. So if you will keep the values equation using equation 2 in equation 1 and squaring on both the sides, you will get h square nu square plus m0 square c to the power 4 plus twice h nu m0 c square equal to uh, 0, and therefore it is written as h nu equal to cp, and therefore 2 h nu m naught c square equal to 0. It implies that either photon energy is 0 or the rest mass energy is 0. So it is impossible, and hence our assumption is wrong, and hence free electron cannot absorb photon. So this is all about the uh, proof regarding photons cannot be absorbed by the electron. Now here these are two main things why intensity of modified wavelength is higher than that of the unmodified for low atomic number scattered during the Compton scattering. Now remember the target materials which is having low atomic number, in that case the number of electrons when photons are incident on the scattering material, and if the photon collides with valence electron which are loosely bound or free. In such collision, photon loses some energy and momentum to electron and undergoes the changes in wavelength. Now this is the Compton effect which we have studied. Okay, but in low atomic mass number scattered, number of free electrons are greater than the number of bound electrons, and hence the intensity of modified wavelength is higher than that of the unmodified wavelength. Whereas in case of the high atomic mass number material, the number of free electrons are more, and for low atomic mass number the scattered during, and hence to study the Compton effect, the target material having low mass atomic number chosen. Now, why Compton shift is not detectable for the visible range of light? Basically, it is the limitations for the Compton effect because it cannot be visualized in case of the UV region, because the range of the wavelength is from 4000 to 7000 angstrom. And if suppose so, for visible light, the for visible light, delta lambda is negligible, and hence it is not observed in case of the visible source of the light. So this is all about the Compton effect. So remember, this Compton effect are related, or it consists of very small various topics. So you should go all these three theories and study it carefully. Then we will see what are the numericals which can be asked on this Compton shift equation. Thank you.